So in the previous video, we had started question 3. This is lesson 4.6, part 3. There's 3 parts to this lesson. So if we look over here, we had the area of a circle given to us, and we know that the area of a circle is pi r squared. So we want to find an expression for the radius of the circle. And for these type of questions, we want to start off by factoring the area given to us. Now this one looks a little complex. Let's write this out. We have area is equal to pi x squared plus 10 pi x plus 25 pi. Now some students might panic when they see that. What do you do with the pi that's there? Well, you can factor that out. It's a common term, so we can take out a greatest common factor here to make things a little bit easier for us. So we have area is going to be equal to, let's take pi out of here. We have x squared plus, if we take pi out of this, it'll be 10x. And then, oops, and that should be 25 pi, not 2 pi. If we take pi out of 25 pi, that's 25. And so we have a simple trinomial here, but if you look at it carefully, let's look at this here. 1x squared is a perfect square. 25 is a perfect square. And the middle term, if you look at that carefully, let's see if that's equal to 2ab. Let's test that out there. So 2 times the square root of the term in front here, so that's 2 times 1, times the square root of this term here, which is 5. That's going to be equal to 2 times 1 times 5, which is 10. So the middle term meets that criterion. So that means that we have a perfect square trinomial, which means that we can just write area is equal to pi times x, because that's the square root of the first term, bracket, squared up here, and square root of the next term is, square root of the last term is 5, and then the sign in between would be plus because the sign here is plus. And so we found that the area is equal to pi times x plus 5 squared. If you didn't notice this is a perfect square trinomial, what you would have done is you would have basically just factored in the normal way, find two numbers where the product is 25 and the sum is 10, and you would have had something like this. So I'm just doing this as an aside to show you. You would have had area is equal to pi x plus 5 brackets x plus 5, and then you would have seen, since they're the same content in each bracket, you would have combined them together to make them pi x plus 5 squared. And so writing it this way actually is quite helpful, because remember that the area of a circle is pi r squared. So if you notice, you have pi r squared. So what we have here is an expression for the area, but we're not quite done. We're looking for an expression for the radius of the circle. So this is the area, which is pi r squared. We are looking for r specifically. We have r squared in our area expression, which is x plus 5 squared. So if you wanted just r, you would take the square root of r squared. You would do the square root of r squared is equal to r. In other words, you would do the square root of x plus 5 squared. And that simply means you're removing the squared sign there. So that means that r is going to be equal to x plus 5. Because you took the square root of this x plus 5 squared to give you, and I'm just going to show you with exponent rules, x plus 5 squared. If you take its square root, what that means is you're basically doing this entire thing, this entire expression, to the power of half. Half times 2 is 1, so it's x plus 5 to the power of 1, which is really just x plus 5. So basically, take square root of your r squared, you get r is equal to x plus 5. And that's your radius. The reason I have to do that is because the question was asking for an expression for the radius, not for the area specifically, and not for the radius squared, and you just need to make that connection. So write out that connection that's in the question, and then things become more clear as you go throughout. So our next part of the question is, now that we have this expression, find what the actual radius would be if x is equal to 10, and then find the area of the circle. So there's two parts to this question. So first, we're going to find the radius. We know that radius is x plus 5. And we're going to go and we're going to replace that x by 10. So 10 plus 5. So our radius is going to be 15 centimeters. And then we need to find the area. Remember, the area of a circle is pi r squared. And so now that we have the radius, we can simply go and plug that radius number into our equation. So we'll get pi multiplied by 15 squared, which is equal to pi times, so 15 squared is 225, and then you can put that in your calculator and you get 706.86 centimeters squared. Now, be careful in the question. Sometimes I would ask you to round to 1 decimal place or 2 decimal places, so just be careful there. Another way you could have written this is or 225 pi centimeters squared. So you could have left it like that as well. So that's our area overall. We found our radius first, and then we used it to find our area. So again, review your area for common shapes that you may have seen before, and then read the questions carefully. We wanted the radius as well as the area. Make sure you use little check marks to help you in doing this. Make sure you put squared up here because it is a surface area that we found. So now we're going to go and do question 4. So we have a computer software company models the profit on its latest video game using the relation p is equal to negative 4x squared plus 20x minus 9, where x is the number of games produced in hundreds and hundred thousands, and p is the profit in millions of dollars. So we want to do the following for this standard equation here. Express it in its factored form. So we have p is equal to negative 4x squared plus 20x plus 9, or minus 9, sorry. Let's see if there's anything that we can take out, anything we can factor out, a greatest common factor. It doesn't look like it. It looks like we're going to have to go with a decomposition technique here. We don't really have perfect squares. You can't do the square root of a negative number yet. So that's not going to work out for us. So what we can do is we can try to find the product that's equal to 36. So a product equal to 36 because it's negative 4 times negative 9, and a sum that's equal to 20. So it looks like we can do, let's see, those two numbers could be 2 and 18, because 2 times 18 is 36, and then 2 plus 18 is 20. So we can go into our decomposition technique. P is equal to negative 4x squared. Oops, I forgot my 20x over here. Decompose that. So we'll do plus 2x plus 18x minus 9. And we'll go and factor things out based on the common groups that we have here. So we'll have P is equal to, from here I can take out a negative 2x, it looks like. So my coefficient will be negative 2x that I'll take out. I want to try to have the x values in my brackets being positive if I can. So when I take out negative 2x, I get 2x over here, minus 1 over here. Over here it looks like I can take out a 9, so plus 9. And if I take out a 9, I get 2x minus 1. And I've created common factors here. So I get P is equal to 2x minus 1. And then the leftovers are minus 2x plus 9. And typically, like I said, what I like to have is my x values being positive in these brackets. So I can pull out a negative 1 from here. So if I do that, I get P is equal to 2x minus 1. Pull out negative 1, so times negative 1. And then that gives me 2x minus 9. And then I can put the multiplication at the front as my a in the factored form. So I get negative 1 over here. I'm not going to write 1 since it's implied. 2x minus 1, and then 2x minus 9. So there I've factored my expression fully. It's equivalent to this form here, just in its factored form, and it can give us some different information. Let's go take a look at question B. For question B, what are the break-even points for the company? So here we're asking you break-even points. What does that sound like? Well, it sounds like we're asking you for your zeros. It sounds like you're asking you, when is the profit 0? That's what a break-even point is. So when is our spending equal to the amount of earnings that we get? So we're just breaking even. We're not losing money. We're not making money either. So we're basically asking you, when is P equal to 0? When are the profits equal to 0? And so we can write that as an expression. We can write negative 2x minus 1, 2x times 2x minus 9 is equal to 0. And so we want to find x values that will make either one of these brackets equal to 0. We're finding what our zeros are. So you can do that with each bracket. You can simply take your 2x minus 1, find out when it's equal to 0. And you can do that by solving for x. So we'd have 2x minus 1 plus 1 is equal to 0 plus 1. We're just isolating our x value, or sending the 1 to the other side. And so we get 2x is equal to 1 divided by 2 divided by 2. So one of our zeros is x is equal to half. That's one break-even point there. And let's see if we have another break-even point with the 2x minus 9. We're solving for that again. Is equal to 0. We'll finish that in the next video, the last part of this lesson.